All right, so we're going to wrap up the last part of the 4-5 notes, actually last part of all chapter 4 notes right here, and with finishing up solving. And honestly, not really going to do anything new today. We're just going to keep working with these, make sure you understand how to solve them, how to check for your extraneous solutions. And that's pretty much it. All right, so when we see these problems with multiple fractions set equal to each other, the general best strategy to solve these are create a common denominator amongst everything. And actually here, we've got two common denominators, and this one doesn't have a denominator at all. So it's really easy to give it one, meaning not going to change this at all. Sorry, it's terrible writing, but this 7, I'm going to multiply it by x minus 2 over x minus 2. And this 10 over x minus 2, I'm not going to change at all either. So basically, I'm going to just do this, just changing this one term. That's going to get me all common denominators across the board. So I've got, once I distribute this out, 7x minus 14. Okay. And then the 10 over the x minus 2 here. So now we're at the same spot we hit yesterday, where we've created a common denominator on both sides of the equation. And since it's on both sides of an equation, anything that's on both sides of an equation can be eliminated. So we go, boom, get rid of it all together. Now you are just solving this numerator equation, which is actually usually pretty easy. So I'm going to want to have, let's just go ahead and rewrite this a little bit better. I'm going to rewrite it up here, save myself some space. So I have 5x equals 7x. And then I'll go ahead and add these like terms. So a negative 14 plus 10 would be a negative 4. All right, so I want to solve this. Let's move this 7x over. Give me a negative 2x equals a negative 4. And divide by the negative 2. And so we get that x equals 2. And then we have to ask ourselves, can x equal 2? Or is it one of our restricted values? And as you can see here, x cannot be 2, right? This would give us a 0 down here. So because of that, this is considered an extraneous solution. And because it's extraneous, and we had no other solutions, we would say that this problem has no solution. And that's our actual answer to this problem. Okay? So you found a solution, but it can't be because that would make this problem undefined if it was just 2. There's no other solutions to pick from, so that's it. All right. So now we see another one here. Kind of similar to the last problem, except now we do have some kind of mismatched denominators here. So we're going to need to multiply them by each other. So sometimes instead of rewriting everything, you can just start kind of like writing it on here. But you may want to avoid that. So I'm going to go ahead and kind of clean this up. So this one's going to need to get multiplied by 4 over 4. Okay. This one's going to need to get multiplied by 4 over 4. Oh, sorry. Saying 4, writing it. There we go. And then this last term is going to need to get multiplied by x minus 3 over x minus 3. Basically, your thought process here should be each denominator needs the other denominator. All right? So each of them got multiplied by something. We're going to simplify this and kind of see how it goes. So I'm going to get a 12 on top here over this denominator. I'm going to get a 4x here over the same denominator. And I'm going to get x squared minus 3x over the same denominator. All right. So same denominator across everything. We can eliminate it because this is an equation. Do not start doing this on the stuff that we learned the last couple weeks. You can only do this on equations. All right. So what do we have? This is going to be a quadratic because see we got this x squared. So let's just rewrite it. We have 12 equals, and we can do the 4x minus the negative 3x. That'll be a 7x. And then also minus the x squared. Be careful with the negative. That gets people a lot. This is a quadratic. So move everything to the one side. Get this to be positive. So if we added the x squared over, we subtracted the 7x over, and we get it so it's set equal to 0. Because this is how we solve quadratics, right? We get everything on one side, and now we can solve it by factoring or quadratic formula or graphing or whatever method you like. This appears to be one that can factor pretty nicely to just x minus 3 and x minus 4. And therefore, the solutions are 3 and 4. Okay? And again, factoring is just a equals 1, so factors of 12 that add to negative 7, negative 3 and 4 work. Once I picked those solutions, I'm feeling good. I like my answers. Last step, check the restrictions. And the only restricted value in this case is x cannot be 3. So, sorry, buddy, you're out of there. This one would be considered extraneous. And this one is our one solution. And again, we don't really know what we're going to get going into these problems. You can get a no solution, you can get a one solution, you can get two solutions. Because it could be possible this one wasn't extraneous and they were just both solutions. That'll happen sometimes too. So don't think it has to be one way or the other. Just every problem's different. You'll get some combination of something. Okay. All right. Let's go ahead and look at these two. And this one here is actually a lot like the very first problem where you have two denominators that are common and one that is not. So I'm going to kind of shortcut this one a little bit. I'm going to say I'm just going to multiply this by x minus 3 over x minus 3. I'm not going to rewrite the whole problem like I did on the other one because I only got to change this one part. We'll save ourselves a little bit of space. So what are we going to get? This x gets distributed. We're going to get x squared minus 3x over the x minus 3 plus 6 over the x minus 3 equals 2x over the x minus 3. Okay, so we only had to change the one expression there. Everything else stayed the same. Now we have a common denominator on both sides of the equation, so we can say see you later. And let's get this as a quadratic. So it's x squared minus the 3x. And then if you can do this, you can, again, shortcut some steps here. We want to subtract this 2 over. So 6 minus the 2 is going to be just a plus 4. We know we want it on that side because this is a quadratic. We want to be able to factor it. So once we get everything on one side, we get it set equal to 0. Now we can factor it and solve it. So factors of 4 that add to negative 3. I'm dumb. Sorry. Let's back this up a little bit. I miswrote this problem. This is a 2x. That's going to change some things. Sorry, my bad. So let's just clean this up and go from there. So what do we have? We have the plus 6. We have the equals 2x. All right, so this is the problem we're solving. Same process, it's just different now. So we want to subtract this 2x over. So now it's going to be x squared minus 5x plus 6 equal to 0. And now we're going to solve it by factoring. Definitely helps when you write the right problems down. So factors of 6 that add to negative 5, that would be negative 3, negative 2. So x minus 3, x minus 2, which makes our solutions 3 and 2. All right, feeling good? Check those restrictions and see if we need to get rid of anything. So a lot like the other problem, x cannot be 3, so see you later. And this problem just has one solution. All right, not that bad. In my opinion, I like these better than the stuff from the last two sections. I think these are not incredibly complicated. You create that common denominator, you get rid of it, and then you solve what you're left with. And then sometimes they are really easy, like this one. This problem already has a common denominator. So you can go right to this, and you just got x squared equals 25. Which, if you want to solve it by factoring, you could move 25 over to here. And you're like, oh yeah, that's x plus 5. And that's x minus 5 because it's a difference of squares. So my solutions are negative 5 and positive 5. But negative 5 is a restricted value, so cannot be 1. So this one just had one solution. Okay, so that's actually a really easy example of the same type of thing. And they can range from, moderate to easy difficulty. I don't really think you're going to see too many that are really hard with these style of problems, okay? So in my opinion, 4 or 5, definitely one of the easier of these three sections here that we're going to be quizzing on. So let's try it out today.